Okay, so I have started the recording. Okay, so what is the original diameter?
Original diameter.
Yes.
It is, I think, the initially diameter. D.
Okay. Yeah. Okay. So D naught. How much is it?
It is 12.8 millimeter.
12.8, and millimeter is 10
That-
power minus 3, right?
Yeah, 10 power minus 3. And the length here, it's L. L, yeah, 50.80 millimeter.
Okay. So this is the.
And yeah,
Okay. And it is full intention. Okay. So next information is given to us that let's say it is a circular cylinder, right? Like this, right? And it is a tension force is applied, right? Okay. So Omar, tell me that when I apply the tension force, so what will happen to this specimen?
it will give a warning and it will fit here, right?
Okay, so it will elongate or not?
Yeah, it will elongate.
Okay, so this is the initial length, right? And this is the initial diameter, this, right? This is D naught, right?
Yes.
Okay, so after when we gave it this tension, Hamza,
Here,
what will happen to the diameter when we apply the force?
it will be more big.
Okay, so L will increase, and what about D?
Will increase.
Huh? What?
Will decrease.
Yes, so D naught will decrease and L naught will increase, right?
Yes.
Okay, so if this were a compression test, let's say this is my specimen, right? And I'm applying a compression force on it, compressive force. So what will happen to this? Well, this is length, right? This is length, and this is the diameter, right? So its diameter will increase or decrease? Omar?
Increase.
Diameter will increase.
And what is length? Length will also
It
increase?
will decrease.
Yes. So,
Yes. Yes.
so length is decreasing, and diameter will increase, right? Okay. So it says that it is pulled until it fracture occurs, right? So after pulling it, right? So it becomes it will become big and it will become thin, right? Like this, right? Okay, so what is this L now? The fracture length, LF. Let's say the fracture occurs here. This is breaking. This breaks specimen, right? So it is break in the middle. So what is the final length? What is the
Final
fracture?
length is 72.14.
And what is the final diameter?
The final diameter 6.60 millimeter. 6.60.
Okay, so it is 6.60 into 10 raised to power minus 3 meter. Okay, so you see that from 12.8 it goes to 72.14, right?
Yes.
And from 50.8 from 50.8 it goes to 72, and from 12.8
Yes.
it goes to 6.0. So it means that this diameter decreased, right?
Diameter decreased and the length,
increased.
yes.
Right. Okay. Okay. So, how can we solve this? Do you have idea?
Yes, of course. We will use the percentage reduction area.
Okay. So percentage reduction.
Reduction,
Area.
yeah, equal, yeah, A dot negative AF over A dot.
Okay. So what is A dot now?
A dot, the initial length. Yeah, it is diameter over 2.
No. What is it? First of all, understand that what is it, right? Okay. So this is my cylindrical
okay.
specimen, right? And this is the diameter d naught, right? Okay. So what is the formula of circular cylinder area?
D over 2.
D over 2 or D
Over
over 4?
No. Okay. That's what I know. It's over 2 and multiply by 2. No. Power 2, sorry. Power for all of them, power 2.
Yeah,
for all. Yeah, put brackets, power 2, multiply by pi.
Yes, so it comes out to be pi by 4 d squared, right?
Yes.
So a naught is this, pi by 4 d squared. Okay, let me go to the other page. Okay, so our percentage area reduction formula is pi by 4 d naught square, right? And pi by
Yes.
4 df square divided by pi by 4 d naught square, right? So pi by 4 is common in both, so it will cancel out, right? D naught square minus df square by d naught square. Okay, so what is d naught?
D naught, the initially, it's, yeah, 12.8.
And what is df?
df
6.60, right?
6.6 here.
Okay. So 12.8. Sorry, 12.8 minus 6.60 divided by 12.8. So how much is it?
Where is the power?
Yeah, okay, so power will also be here.
Yes, okay, I will calculate it. It is 0.73.
0.73. It is equal to 73.
I think we have to, we have to multiply it by 100.
Yeah.
Okay.
So it is percentage of 73%, right?
Yes.
So this is basically ductility, right? 73%
Yes.
ductile, right? And now
Yes.
percentage increase in length.
For EL.
Elongation, right?
Elongation, yes. It is it is LF negative L dot, yes, over L dot, yes.
What is LF?
LF the final result of the length.
Okay, so
The final.
72.114. What is the initial?
The initial, it is 50.8 over 50.8.
How much is it?
Okay. It is 0.42.
Okay, so is this question good or wrong, difficult or easy?
Very easy. Hamza,
Easy.
it is easy or no?
Easy.
Easy, okay.
Okay, so easy. Good.
I hope it will come in the exam.
Yeah, I hope.
Yeah.
Okay, now let me bring the second question, right?
Yes. Okay.
Are you here?
Yes. The professor said it is very important, this question.
This question.
Yes, he said he might it may come in the final exam.
Okay, so I have already explained this topic in the lectures, right? Chapter 9 lectures.
Yeah, I saw it, but just do a revision for it.
Yeah, I'm doing revision. I'm doing. Don't worry.
Okay.
Okay, so this graph is what alloy? When you look at this graph, what is this alloy?
You mean liquid and solid like this?
Yes, no, it is a eutectic alloy, right? Eutectic alloy.
Oh yes, eutectic.
And why it is eutectic?
Because there is liquid and solid and beta like this.
No. This is the point. I told you this is the point. Okay, so the liquid is directly converting to solid, right?
Yes.
And you see here in all the other diagrams, first the liquid convert to alpha plus liquid and then alpha plus beta, right?
Yes.
So due to this eutectic point, these alloys are called the eutectic alloys,
Eutectic,
right?
okay. Yeah.
Let me bring out a question, exercise question, so that you can betterly understand, right?
Okay.
A lead tin alloy of composition 30 WT% SN, 70 WT% PB is slowly heated from a temperature of 150 Celsius.
Okay. So what is the first part? Now we are given with the 30 weight percent SN 10 and 70 weight percent PB. Okay, so when you are given with this information, right? Then you will look at the x-axis of the diagram, right?
Yeah.
Yes.
Okay, so what is the x-axis of the diagram? It is PB or SN?
SN.
SN?
I think SN.
Can you zoom out and see clearly?
Down right or left?
No, on the x-axis. Yeah, it is SN.
SN, yeah.
Okay. Okay, so you will locate a point, right, of 70%.
Yeah.
Okay, so this is 60, right? This is 60 and this is 70, right?
Yes.
Yeah, the 70 for PB.
For SN. Oh, sorry. Sorry, this is not our interest. Our interest is SN, right? So let me clear this. Okay, so this is 20, right? Can you see?
Yeah.
This is 20 and this will be 30, right?
Yes.
Okay, so this is 30. Now we got our point. Now it says that it is slowly heated from a room temperature of 150 degrees centigrade, right?
Yeah.
Okay, so this is 200. Let me see again. Is this 300 or 200? The picture is very blurry.
Where?
This is 100.
It is 100.
And this 200.
Yeah, 1.
200,
Yeah.
300.
Okay. So this is the half point, right? This is the middle point. Okay, so
yes,
you will draw a horizontal line and come out to this 30 degrees centigrade, right? So from here we start heating, right?
Yeah.
yes.
Okay. Okay, so at what temperature does the first liquid phase form, right?
Yes.
Okay, so at what temperature? Now, when you go above, you will draw a vertical line from there, right? And just a straight vertical line, right?
Yeah.
Okay, so it stated that at what temperature does the first liquid phase form, right? Okay, so you have alpha plus beta, right? At this point, right?
Yeah.
At
Yeah, alpha plus beta. Yes.
temperature 150 degrees centigrade, and the composition is alpha plus beta. And now you slowly heat up. You open the pipe, right? Okay, so first it will convert to alpha plus liquid, right? And then it will go to liquid as depicted from the graph, right?
Yeah.
So first step is alpha plus liquid will form, and then thirdly all will be liquid, right?
Yeah.
Okay, so it says that at what temperature does the first liquid phase form? Okay, so this is the point. This is our point of concern, right? At this point, the liquid forms, right?
Yeah.
Do you understand what I'm saying?
Yes. Yes.
Okay, so when you draw a horizontal line and connect this to the temperature axis,
But it's not only liquids and something.
but it says that the first liquid phase, right?
Okay. Okay. Okay.
So it is the liquid phase here. Okay,
Yeah.
so
Okay. Okay.
okay, so it is almost close to 180, 182, 184. Okay, so the temperature is 184. For the part A, our answer is 184, right?
Okay. Yeah.
It is for first liquid.
Yes, yes.
You know what? From where?
What?
How did you know?
Okay, so here is written this alpha plus liquid, right?
Yes.
Okay, so this is the alpha plus liquid region. Okay, so this is the liquidus line, right? This horizontal line. It's
Is it this liquid?
Yeah, this is the liquidus line. So above this alpha plus liquid, and below this alpha plus beta, right?
Yes.
So when we are just entering to this alpha plus liquid region, so you will know that temperature. It is 184 or 185, 185, right?
Okay. Yes.
Okay, so and now what's the composition of the liquid? What is the composition of the liquid? Can you answer this question, Umar?
I don't have any idea.
And what about you, Hamza?
Not sure about that.
Why?
Wait a moment. What the composition?
The composition of liquid.
No, I forgot.
Okay, okay. Okay, so this is the point, right? Okay, so let me draw okay, so this is our line, right? Right? This is
Yes.
our point. And we will draw a tie line. So a tie line will be above this line, right? And it will touch the alpha line here. This is the alpha line, and it will touch the liquid. This is the liquid line, and it will touch the liquid line here, right? So
Yes.
when you move down, and you look up here, right? You move down this eutectic point at which the liquid line crosses your tie line. So I will draw a tie line here, right? Like this, and our liquid line. Okay, so it is already written here that it is 61.5, right? Okay, so already written here 61.9, right?
Yes.
Okay, so the composition of liquid for the part B, our answer is 61.9 Cl. right? Weight percent of SN, right?
Is it that mean that it has, I mean, for all the lines here for the liquid and solid, it has to like to achieve all on this one point?
Okay, so when our cooling, our heating reach at this point, right? So this point
Yes.
correspond to what is the temperature? 183, right? So 184 degrees centigrade. So this is the 184 degrees centigrade line. So when it here, right? So it says that how much weight percent of SN is in the liquid and how much weight percent of SN is in the alpha, right?
Yes.
Okay, so the composition of liquid, I already told you that we can find by drawing a tie line. So from this point, you will draw a tie line, and this is the liquidus line, right? This is the liquidus line. So you will see that where my point that the liquidus line crosses. So the liquidus line crosses at this point. This is also the eutectic point, and it is also written here 61.9, right?
Mm-hmm.
So the composition of liquid Cl is 61.9, right? And you get my point.
Yes.
Okay, Hamza, do you get my point?
Yes, yes.
Okay, so what is the part C now?
At what temperature does complete melting of alloy occur?
Okay, it's complete melting, right? Complete melting.
Complete melting, yes.
Okay, so at this point, at this region, it will be alpha plus L liquid, and at this point, it will go to liquid. This is the liquidus line, right?
Mm-hmm.
Okay, so what is this temperature if you read out?
The temperature is 250.
Above 250, right?
Oh, 260.
It is almost 263. Okay, and it says that what is the composition of the lost solid remaining prior to complete melting? Okay. Okay, so at this point, you will notice that how much weight percent of this alpha is, right?
Yes.
This correspond to fully melted, right? And at this point, you will draw a tie line, right? A tie line will connect to the alpha region, alpha line, right? And an alpha line, you will note down, you will move down, and you will note down the composition. Okay, so how much is this?
It is maybe
It is 10 and it is 20, so it is almost
maybe 18.
14, right? Because it is just in the middle.
Oh, okay.
So C alpha is what? So this was basically a very easy problem, right?
Do I have to write like the red I mean the theoretical look in the down of the paper?
Okay.
Yeah, they write like a lot of things. Do I have to write all of these or no?
You?
Yes, in the exam.
Yeah, in the exam, if they ask you, then as I draw the diagrams and I draw all of these, right? So I told you in English, then you can explain to your professor that I got the CL 61.9. So you should explain the process that I draw a tie line, and at this point it touches my liquidus line, right?
Yeah, that's what I mean. I want like for you to write this, you know?
Oh,
Yeah, to be clear for us.
okay, so part A. Note it down. Did you note it down? Hello?
Yes.
Do you write these?
I will take a picture. Okay, just a second. Okay.
But your professor will not ask you about this this English, right? This theoretical.
Like I don't know if he will ask us for this or no, but maybe it will be better.
But in the question it says the composition of the liquid. So this is basically what you have done, right? So you will explain the process. I think it's if the process is clear to you, then you can write these. This is not something. The main thing is that you should know these, right?
Yes, I get you.
What about part C? Part C says that melting alloy. Okay, so moving up, the melting occur at the liquid line. Hence T is equal to. And for part D is simple. We draw tie line. And C alpha is equal to